Hello, calculus fans. All right, let's suppose that we have a quantity y, and this is going to depend on another quantity x. So y is a dependent variable, x is an independent variable. So y is a function of x, and often we'll write y is equal to f of x. And let's suppose that the value of x changes from x1 to x2. And so what we're going to say about the change of x, which is also known as the increment of x, we're going to call that delta x, which is equal to x2 minus x1. That means the corresponding change in y is delta y, which is y2 minus y1, and that's the same thing as f of x2 minus f of x1. So all we're doing here is introducing a little bit of new notation. Now we can say that the average change of y with respect to x on the interval from x1 to x2 is given by something called the difference quotient. We've been using this already. We're just, again, talking about this in a slightly different way. Delta y over delta x is equal to f of x2 minus f of x1 all over x2 minus x1. Now we've got a lot of different interpretations of this quantity, depending on our context. It could represent the slope of a secant line, or it could represent the average velocity of an object. Next thing we're going to do is we'll see what happens to this average rate of change as we look at smaller and smaller intervals. x2 is going to approach x1. So that means delta x goes to 0. Remember that delta x is the difference between x2 and x1. The limit of these average rates of change is called the instantaneous rate of change. Sometimes we'll just say rate of change. And that's the instantaneous rate of change of y with respect to x at x1. And we have a lot of interpretations of this quantity also. And again, it depends on the context. It could be the slope of a tangent line. It could be the instantaneous velocity of an object. Sort of depends on which way we're looking at this. Okay, that's all for now.